Hello, it's me, and I've got a viewer question from a viewer by the name of A Bag Deadpool. Great name, by the way. He was having some difficulty in the last layer of the layer-by-layer approach to the 7x7. So I did that quite some time ago, and on reviewing that, I think maybe I could have been a little more clear regarding that. So I'm going to go through that again. But what I did first is I put it in exactly the configuration that he got it, which, by the way, is a really fun challenge with some of these viewer questions. That's why I keep asking for pictures of the dilemmas, because I really like trying to get it back into that configuration. Now, I don't know if I'm going to be able to show it, but take my word for it, that's what it looks like. First he showed it here, and you can see this configuration here. Then he showed this over here, and here. Came back around to here, I think, and to here. But in any case, if you look at it, all of these sides look exactly like what he had. Now, I think the main dilemma that was going on is that he was having a hard time pairing all the edges and a hard time flipping this. So what I'm going to do before I dive into that, I'm going to go through a kind of a quick summation of how to deal with the last layer of a 7x7 because the way that I'm going to describe this is going to make more sense. So I'm going to forego with all the other layers. Here's a sister 7x7. But so let's say you've done all of these. And by the way, if you wanted me to go through another layer by layer tutorial, I can do that. But I think the only part that I could be more clear on is the last part. So the first thing that you want to do when you've almost finished it, so you've got all the other layers, you're really excited because it's 7x7, it's an over-the-top kind of a puzzle where it's just got more layers than it really needs, but you're having a hard time getting all of this paired up. So the first thing to do is we're going to start off with these edges over here, so these central edges. And what you want to do is you want to flip all of these first. Now this is a way of doing this last layer with doing minimal motions of the previous layers, except if you had to do corner swapping algorithms or things like that. So you're going to do this the same way that you do a 3x3. Anyway, so basically it's exactly like a 3x3 algorithm. You can see this is rotated up, this is rotated up. Now this will not have any parity issues because it's an odd layer puzzle. So because you have two up here, this is that line formation. So either none of them are up, that's a dot, two of them are up, but in this configuration, that's an L, or these two, which is a line, or they're all up. So do it just like you would a 3x3. So holding it over here with these two, basically it's a 3x3 strategy. You do the algorithm, this is a line formation, F, R, U, R, I, U, I, F, I. Now that's probably not too hard, and you've probably figured that out. So you see these are all lined up. The next thing that you're going to want to do is we're going to just solve these guys here. And the first thing that you want to do is get all of these rotated in the proper position. So this is rotated right, this is rotated correct. It doesn't matter at this point what the color is, what the specific color is, you just want all the yellows up. So what I'm going to do is I'm going to do corner swaps because I want to pair those that are upside down with each other. For instance, I want two that are upside down here, two that are right side up here, however you want to do that. So we're going to do this by way of corner swaps. Now, I'm only going to be moving this and this. This is my R move here. This is my L move here. I'm not paying attention to anything on the outside, just these two. So if I were to do a corner swap, an adjacent corner swap, this would come over to here, which is good because a right side up will pair with another right side up. So these two will flip. So this will end up here, and you might think, oh good, we've got two that are upside down, but these two are going to flip. That would be okay, because when this comes here, this will come here. I'm now going to have two that are flipped upside down, two that are flipped right side up. This will be here, so these are going to be out of sync, but that's okay for now. So I'm starting to slowly kind of put them together. So I'm going to do a corner swap to pair up those that are oriented in the same direction, whether it's upside down or right side up. So holding it here, just moving this, doing an adjacent corner swap, which will flip these two and these two. We go 2R, U, 2R, UI, 2R, UI, D, 2R, UI, 2R, U, 2R. Cuboid strategy, that's all it is. So you see these are paired, and these are paired. They happen to be the same color, but they didn't necessarily have to be. It's just how it turned out. Okay, now that I've got that paired, I'm going to do the same thing here. Doing a corner swap, we'll swap these two. So this will go here, this will go here. That'll be good because I'm going to be pairing two that are upside down. I'm going to forget the center here, remember? And then these two will swap, which will be okay because I'm swapping right side up for right side up. So this will bring this over here, this will come over here, these will swap, but those will be right side up, and both of these will be upside down. Basically, the ones that you have left, put one over here and the next one to swap over to here. And these will just kind of, I don't know, fix themselves. So anyway, these here and these here. This is what I like about the last layer because it takes some strategy and some planning. 2R U, 2R UI, 2R UID, 2R UI, 2R U, 2R. Bring it back. Okay, this is what we want. We're just dealing with these edges over here just to the side of the central edge. So right side up, right side up. These are upside down. What I'm going to want to do now is I'm going to want to simply flip-flop these two. And that's done by the Red Bull algorithm. And what that does is that flips these two and turns it upside down. We're going to do it with this one, and then we're going to do it with this one. The way this works, it's called Red Bull because you start off with 2R, 2B, 2U, L, spelling out Red Bull. Then do 2 up, RI, 2 up, R, 2 up, 2F, R, 2F. Then finish up, think of liberate. LI, 2B, 2R. Get it? Liberate. Anyway, so you see that these are flipped. We'll do another Red Bull to get this flipped as well. 2R, 2B, 2U, L, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, LI, 2B, 2R. This in the SUNY I find to be the most useful of algorithms. So you see these are all facing the right direction. The next thing that I'm going to do is I'm going to start pairing the colors. So I want to move all of these in. Now that they're in the right direction, now that they're oriented, I now have to permute them. So it's going to be the same thing. It's going to be corner swaps. These two are already paired. I don't worry about the central one either. I'm going to try to pair these corner areas here. This, well, needs to pair with the green, which is over here. So what that's going to mean is these two are going to swap, which is good. This orange will come over to here, and then this blue will swap with this orange, so that's going to do it. Now it doesn't always match up that way. Sometimes the green isn't over here, sometimes it's over here. If that's the case, then you're going to have to swap these two. Anyway, so this is just the configuration that this happened to be. But at its most simple form, that's how you're going to do it. So let's go ahead and flip-flop these two. 2R U, 2R UI, 2R UID, 2R UI, 2R U, 2R. This moves back. So what you're going to see is that these are paired, these are paired, these are paired, and these are paired. The next step that I do is I now move these central edges with the proper corner edges over here, and that's just done through edge swaps. Not corner swaps, but edge swaps. But bear in mind, anytime I do an edge swap, I'm going to create misplacement on here and here, so I have to coordinate that. So I'm going to move this blue to here by doing an opposite edge swap. 2R, 2U, 2R, 2U, 2R, 2U. You see these are all paired up here. I created misplacement, but maybe we can fix that in the wash, so to speak. Moving it over here. I can move this orange to here, and it'll get this back. 2R, 2U, 2R, 2U, 2R, 2U. Okay, so you can see all these are paired and all these are paired. What about these two? Well, I could do an adjacent edge swap and do that algorithm. These are cuboid algorithms. If I do that, they're going to be paired, but I'm going to create misplacement here, and I don't have another one to pair to take it out. So that's a situation where I have a problem with pairing these and creating misplacement. When that happens, what I would do is move these opposite each other. So I'm going to do SUNY using this. So anytime I want everything to move, I'm going to use this as my R. When just moving these guys, I'm going to move this as my R. But a SUNY will make this go over to here eventually. So R, U, RI, U, R, 2U, RI, and you can see they're opposite. When they're opposite each other, I can do what I call the URF algorithm. That will take these and put it here, and take this and put it here, without causing any misplacement. Now I could have done that with any of these, but I figure it's just easier to do it this way. So hold it over here, with this to the left, this to the right, and do 2U, where all of these three are U, 2R, 2F, then I do a 2U, and the layer just above this, 2U, then 2F, 2R, 2U, and lo and behold, you've swapped them and you're good. So these are all in. Now I'm going to move outward over here. This has all been reduced. Same strategy. First thing I want to do is I want to rotate all of these in the proper position. So I'm going to pair those that are not rotated and those that are rotated correctly. So let's see how this is going to work. I want to put the one, well, so these two are already rotated out. So they're paired together. So that's pretty good. So I got to pair these two. So what I'm going to do is I'm going to take this, keep this over here, and I want this guy to come over to here. So I'm going to put this to the far left. This I want to go over to here. So I'm going to SUNY this until this ends up over here. So RU, RIU, R2U, RI. This keeps this the same. It's not there yet. RU, RIU, R2U, RI. Okay, so let's see what's going to happen. What's going to happen is that if I do a corner swap using this instead of this, because I'm done with that, these two will swap, which is good. These will be paired. I'll have this to here, so these will be paired. However, these are also going to swap. And I'm going to end up with a problem because this will be rotated right, this will be rotated wrong. So what I'm going to do first, before I do that, let's go ahead and just rotate this in the proper position. So hold it here, and let's Red Bull this into submission. 2R, 2B, 2U, L. 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, LI, 2B, 2R. Okay, now I did that to rotate this up, but also so that I could take out any issues when it comes to corner swapping. These two will swap, so two wrongly rotated ones will be together. And then when this comes over here, this will be rotated correctly, just like this. These will swap, but it doesn't matter because they're also rotated correctly. So that way it takes out that problem. So we'll do another corner swap, but now this is the corner because I'm that much further out at this point. 2RU, 2RUI, 2R, UID, 2RUI, 2RU, 2R. This moves back, and as you can see, these are just here, and I'm one Red Bull away from getting entire orientation of the last layer. 2R, 2B, 2UL, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, LI, 2B, 2R. Okay, so you've got all these in. Now it's time for the second half. The second half is now we want to pair the colors with each other. Now we want to pair these colors with each other. These are already paired. These are not. These are not. So holding it here, I want to get the red one over to here, but it's all the way here. So how am I going to do that? Well, SUNY's not going to work. They're kind of out of alignment. What I have to do is I have to take this with the green, and I'm going to do a swap, because it's only in that way that I'm going to reconfigure this. Because when I swap it, these two are going to end up over here. Now alternatively, if I don't want to cause any placement issues, why don't I just URF it? I'm going to URF this to here and this to here. Because what happens is these two swap, and then these two swap. So let's see what happens when we do that. To do the URF, I'm going to be moving it from here because I'm swapping these guys. To swap these two, I move it from here. So to swap these two without causing misplacement, I'm going to go 2U, 2R, 2F, then I'm going to do a 2U, and then the layer just above 2U, then 2F, 2R, 2U. Okay, so that cleanly put the green one here. So now when I do an adjacent corner swap, this green will come over to here. Right next to this red will come here, but then these two will swap so that this red will come here, this yellow will come here, and nobody will get hurt. So let's do it. 2RU, 2R, UI, 2R, UID, 2R, UI, 2R, U, 2R. This moves back. Okay. So these are paired, these are paired, these are paired, and these are paired. So now we're going to do the same thing. Doing edge swaps, we'll move these to where they're supposed to be. These two will swap, then these two will swap, there'll be no troubles. So 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R. Okay, these are in. I'm going to do the same thing with these now. 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R. Okay, so now all of these are lined up and you're good. Now, you're going to potentially get a situation where it's not going to work out quite so good. You might get a situation that looks a little like this. Okay, so what's wrong with this picture? Well, you can see that we're just, the ones that are just adjacent, these are not in, these are in, these are in, and these are not in. So this is something that I wasn't able to show in the last time. It was just a look at the draw, so to speak. But this is a situation where adjacent corner swaps are not going to place these because these are already placed. So I can't do an adjacent corner swap because if two are placed and two are not, it's not going to work. This is very similar to what I call the floppy parity because I got this with floppy cuboids. And this is a situation where you need to do a clean swap of just these two, and you're not going to do that with an adjacent corner swap because two sets of corners will swap. So the way that you have to get out of this is you do no new algorithms. It's the same thing. It's just the Red Bull algorithm. But what we're going to do is we have to take this, we're just going to move this up like so. Why? Because I'm going to take this and do the Red Bull to swap these two. This yellow and orange will end up over here, so when I turn it back, this yellow and orange will be paired with it. And won't be any problems. So let's see what happens when we do that. We're going to move this down. Now in this position, do a Red Bull algorithm. 2R, 2B, 2U, L, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, Li, 2B, 2R. Now having done that, remember to just move this up like so. So now you see these two are paired and these two are paired. Now there's a little bit of a price to pay and these centers got mixed up, but that's okay. Sliding U techniques will easily bring that back. This was a key technique of solving all your lower layers. Now what that is just take these three, I'm going to slide it in with this layer. Then I'm going to move this, slide this U so to speak, over to here, and I'm going to move all the layers that don't intersect with this down. So that's these three move down. I'm going to slide this back, bring this back up, slide this back down here, and then bring these three layers back up over here. You should know how to do this or else you would not have been able to get these previous layers. These two, again, put them into place over here, slide this to a different set of layers, these two, bring it down. Slide it back, bring this back up, slide this back, bring this back up. And no worries. So it doesn't matter whether you find that here or here, the technique is the same. Once you've done that, you pretty much have it. Now what you can do is however you want to solve it. This is basically the solve that you would with the last layer of a 3x3, so do it any way you want. Okay. So the reason that I did that is so that I can, number one, answer the viewer's question, and number two, go through a little bit more detail in the last layer of a layer by layer solve. Because I'm telling you, when you have large over-the-top cubes, it's just more fun that way. Because it takes a little bit more strategy with that last layer. Okay, so let's get back to the question here. Well, first off, you did a good job. What you did is you did a good job pairing these. You can see that these two are paired, these two are paired, these two are paired, and these two are paired. So before moving even to this next part, what I would do is let's just go ahead and finish all these three pairing over here. So I'm going to take this and move it to here, doing an adjacent edge, an opposite edge swap. So I'm going to go 2R, 2U, 2R, 2U, 2R, 2U. You can see these are in. And now I'm going to do an adjacent edge swap over here by going 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R. So now you can see these are completely paired. What you now want to do is you want to flip these. You want to line them up together and do a Red Bull algorithm. The best way to do that is get one to your left. Now we got to move this over to here. And I'm just going to do a SUNY to do that. Take all of these and on block move them to here. RU, RIU, R2U, Ri. Remember with SUNY, this does not change. Now this is here. So if I do an adjacent corner swap, these two will swap, which will pair these together, and these will make some noise over here, but they're already, you know, rotated correctly. 2R U, 2R UI, 2R UI D, 2R UI, 2R U, 2R, move this back. Okay, you can see these are now together. Go ahead and Red Bull this into submission. 2R, 2B, 2U, L, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, LI, 2B, 2R, and there you have it. Okay, now that you've rotated all these where they're supposed to be, you just have to match the corners. You see, well, by corners I mean these more terminal edges here. So these are matched up. You see the red over here. You don't see the red over here. To flip-flop, it's over here. So the way that that's going to work is go ahead and either do an adjacent edge swap or just do a URF. I prefer the URF because you don't create misplacement here. Hold it over here to the left and to the right. Do 2U, 2R, 2F, then 2U, and then the layer right above it, 2U, 2F, 2R, 2U. Okay, so that'll put the purple one here and the purple one here. 2RU, 2R UI, 2R, UID, 2R UI, 2RU, 2R. This goes back. So what you've done is you've now matched up these corners, and all you got to do is do center swaps, or rather edge swaps, to get these back in. So red and blue, we've got, well, these, red and blue. So in your particular case, this is easy. Let these be your edges, and these be the corners. 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R. That's your adjacent edge swap. So these are all in, these are all in, and now we're going to get these in, which will replace this. 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R. So that's basically it. Now what you have is you have it completely reduced. You just have the last layer of a 3x3. And you can get it in any way that you want in this particular case. You can go ahead and rotate these up, or we can put the edges in. This is in and this is in. Hold it over here. Do a SUNY. RU, RIU, R2U, RI. That puts these edges in. See which of these corners are correct. This one is, so we're going to rotate these guys around. U, R, UI, LI, U, RI, UI, L. I assume knowledge of how to do a 3x3, which is why I'm moving fast with this. These aren't rotated in yet, so you do it again. Turn and turn. So now all these are in. We just RIDI-RD, RIDI-RD. Bring this all the way around. And you keep doing that until the whole thing is solved. And finally RIDI-RD. Okay, so I hope that helped, but that's how you get out of that very specific situation, and that's how you can do the last layer of layer by layer 7x7 solve. I highly recommend this for most big puzzles, and you can do it no matter how large, how big, and how complicated the puzzle may be. A layer by layer would be most enjoyable. Thanks for watching.